Okay, so we're going to determine whether these matrices are inverses. And so we're given matrix A, matrix B. The first thing, in order to be inverses, you have to be the same dimensions. So this is a 3 by 3, this is a 3 by 3. Okay? And so to check to see if two matrices are inverses, okay, so here's the formula to find the inverse. The inverse notation means a to the -1. So if you see that, that means inverse. So to check whether two matrices, A and B, are inverses, multiply them, and you should get the identity. Okay. I also need to add, because multiplication is not commutative, you need to multiply both ways. So I need to take matrix A times matrix B and get the identity, and then take matrix B times matrix A and get the identity. Okay? And the identity is all ones along the diagonal, right? And zeros elsewhere. So to see if these two matrices are inverses, I have to multiply them. So I'm going to take A times B. One, -2, -1. 0, 1, 1, 2, 1, 2. I'm going to take that times B. Okay. Now you may recall that in order to multiply two matrices, the number of columns here has to equal the number of rows here. Or if the matrices are the exact same dimensions, you could always multiply those. So we're going to take the first row times the first column. Now we're going to do this math in our head. Okay? So 1 times -1 is -1, right? And 0 times -3 is 0. And 2 times 1 is 2. So we have -1 plus 0 plus 2, which is 1, correct? You see how I got 1? No? Because for this box is 1 times -1 plus 0 times -3 plus 2 times 1. And when you do all that math, you get 1, because that's -1 plus 0 plus 2. Okay? So this is 1. Now if you got any other number besides 1, you could stop. Because in order to be multiplicative inverses, you need the identity. And the identity always has 1 here. 1 along the diagonal, okay? And so I should be getting a 0 next. So I'm going to take that row times the second column. Okay? So 1 times -2 plus 0 times -4 plus 2 times 1. That's -2, that's 0, that's 2. -2 plus 0 plus 2 is 0, right? So we're off to a good start. Now I'm going to take that row times the next column. And just to kind of help us out, I'm taking that row times that column, right? So I have 2 plus 0 plus -2. 2 plus 0 plus -2 is 0. Now, I'm going to go to my next row, which is this one. I'm going to take it times the first column, and that's going to go here, and there should be a 0. Okay? So -2 times -1 is 2, so think of 2, plus -3 plus 1. 2 plus -3 plus 1 is 0. Next, I'm going to take the blue row times the middle column. Negative 2 times negative 2 is 4. 1 times negative 4 is negative 4. Right? And 1 times 1 is 1. So you have 4 plus negative 4 plus 1, which is 1. Which is what we want. We want 1s along the diagonal. You guys see how I got 1? And then that row, 2, 1, 1, times the third column. Negative 2 times 2 is negative 4. 1 times 5 is 5. Negative 4 plus 5 is 1. And then 1 times negative 1 is 0. 1 plus 0 is, wait, should be 0, right? So that's negative 4 plus 5 is 1, plus negative 1, that is 0, right? Yeah, so it should be 1, 1, 1, and then zeros everywhere else, okay? And now, I go to my third row, and I take it times my first column. So I'm taking this row times that column. So I have 1 plus negative 3 plus 2. 1 plus negative 3 plus 2 is 0. And then times the middle column. That'd be negative 1 times negative 2 is 2. 1 times negative 4 is negative 4. 2 times 1 is 2. So 2 plus negative 4 plus 2 is 0. And then here, negative 1 times 2 is negative 2. 1 times 5 is 5. 2 times negative 1 is negative 2, right? So we have, let's write that one down. So that's negative 1 times 2 plus 1 times 5 plus 2 times negative 1. See, this is negative 2. That's 5. That's negative 2. Negative 2 plus 5 plus negative 2 is 1. So, do we know that matrix A and B are inverses? Did we get the identity? Yes? We did. Is that enough? To show that two matrices are inverses, you have to take A times B and B times A. So guess what? We're only halfway done. Now, we have to take B times A. So this matrix which is matrix B times matrix A okay? And just to save time, if you take this matrix times this matrix, and feel free to do the math to check my work, but you also get 1, 0, 0, 0, 1, 0, 0, 0, 1. If you don't believe me, multiply it, okay? I already did earlier, okay? And so you could say, since AB and BA equal the identity, this means A and B are inverses. Okay. So in the homework, they're going to give you two matrices. To find out if they're inverses, you have to multiply them one way and then the other way. And as long as you get the identity, which in a 3 by 3, this is the identity, then you can say they are inverses. Okay, the identity of a 2 by 2, basically you would cover up this part. Okay, that's the identity of a 2 by 2. And identities could be, they go on forever, okay? So what I want you to try yourself, this is a little simpler problem because it's a 2 by 2, and a 2 by 2. And I want you to tell me, are these matrices inverses or not? Go ahead, try.